DeepSeek V4 Flash 0731 has just posted an 89.0% score on the ARC-AGI-1 benchmark. The official results page details the economics: 89% on ARC-AGI-1 for 2 cents per task, and 61.4% on ARC-AGI-2 for 4 cents. Historically, reasoning performance at this level was restricted to frontier models with flagship pricing. Today, that same capability is being measured in single-digit cents. These figures are tied to the model's highest reasoning setting, labeled by the benchmark as max effort. If you need immediate breakdowns of AI benchmark results the day they land, subscribe to the channel. This combination of a verified near-ceiling score and a 2-cent price point establishes a new baseline for how open models are expected to perform relative to their cost. The provenance of these numbers is the critical factor. A typical week of vendor announcements rarely produces data with this level of evidentiary standing. These scores carry the semi-private label, meaning they were measured on a specific set of evaluation tasks. These tasks are held out from the public internet. This provides the strongest possible resistance against the model simply memorizing data it found during training. This distinguishes the result from the Prime Intellect 95.5% score on ARC-AGI-3 we covered 2 days ago. While Prime Intellect measured its own performance, DeepSeek was measured independently by the organization that maintains the benchmark. Having the benchmark's own organization stand behind these numbers flips the burden of proof onto every other lab still quoting self-measured scores. In this environment, the identity of who executes the evaluation is as significant as the score itself. To see why this matters for researchers, we have to look at the 3 reasoning effort variants: max, high, and low. This data grid compares these settings across ARC-AGI generations. Notice the ARC-AGI-3 column is entirely empty. DeepSeek hasn't provided data yet. In the ARC-AGI-1 row, there's minimal decay. As effort decreases from max to low, the score only moves from 89% down to 84%. This narrow 5-point spread indicates ARC-AGI-1 no longer needs massive internal search. It's nearing the limits of what the benchmark can measure. But look at the ARC-AGI-2 row. Here, performance collapses, falling from 61.4% at max effort down to 46% at low effort. That 15.4-point spread proves that the newer benchmark is highly sensitive to the amount of compute effort the model applies. For researchers, the gradient of a single model scaling across 3 compute settings is a cleaner probe into benchmark difficulty than comparing a leaderboard of different models. Compute buys vastly different results depending on the generation of the test. ARC-AGI-1 is nearing saturation, while ARC-AGI-2 is where the actual frontier of discrimination lives. Beyond the top-line aggregate scores, the system is processing a massive catalog of complex, individual logic tasks. ARC-Prize has published the per-task pass and fail results for the public evaluation sets. This covers 400 tasks for ARC-AGI-1 and 120 tasks for ARC-AGI-2. This allows researchers to conduct error analysis without spending $1 on compute. You can now identify exactly which categories of visual abstraction still fail, even when the model is running at max effort. Publishing outcomes at the task level allows the community to pinpoint exact blind spots rather than relying on a single top-line percentage. While the model weights are currently on Hugging Face, there is a gap in the available data. The model card is currently unreachable, returning connection resets upon multiple fetch attempts. Because of this, specific hardware facts are deliberately absent. We cannot verify the parameter count, the active parameter count, or the context length. The question of whether this runs on a single GPU cannot be answered from verified sources yet. Until primary source verification is available, circulating claims about the model's size or its API pricing should be treated as unverified. The 2-cent and 4-cent figures are benchmark-specific numbers based on small puzzles, not quotes for general enterprise workloads. Builders should measure the performance gradient on their own specific tasks before committing to a compute tier. While the benchmark scores are verified, the physical hardware footprint and enterprise readiness of the model remain unknown. We must apply a caveat here, because the most impressive number on the page lacks a methodological foundation. The claim of 2 cents per task is quoted with no attempt count, no retry policy, and no token totals. We do not know if this represents a single inference pass or a best-of-n sampling strategy. 2 cents for a single attempt is a very different economic claim than 2 cents amortized over many internal samples. The verification itself functions more as a badge than a comprehensive technical report. The page does not describe the evaluation procedure, reports no variance, and does not state the size of the semi-private sets used. A per-task cost stripped of its attempt qualifiers is a metric that can easily overclaim when repeated without context. There is also a risk in summarizing this simply as 89% on ARC. This graph shows the reality. The exact same model at max effort drops 27.6 points when moving from the first-generation benchmark to the second. Removing the version number from the headline erases this significant capability gap. Additionally, no comparison can be made to ARC-AGI-3, where DeepSeek currently has no data. The immediate signal to watch for is third-party replication on the 400-task public set using the released weights. If public set runs land near the 89% semi-private score, the capability is confirmed. But until then, you must recognize that ARC-AGI-1 is nearing completion, while true reasoning boundaries are tested on ARC-AGI-2.